Okay, let's simplify this. We need a common denominator on the top and the bottom. So we're going to multiply the 3 by x over x, which is 1. So let's start by making that 3 into a fraction, and we're multiplying it by x over x. I'm doing the same for the 5 in the denominator, and that gives us 1 plus 3x over x and 1 minus 5x over x. Now let's rewrite this as a division problem. And then let's apply the KFC, keep the first, flip the second, change multiplication to, or change division to multiplication. Alright, and now let's put parentheses around these binomials, so remember they are factors that are being multiplied together. Now we can cancel like terms, and we are left with our answer, 1 plus 3x over 1 minus 5x. Here we have a subtraction problem that we are supposed to solve. That means we're supposed to find a value or values for y that make this equation true. Alright, that means we need to simplify, and let's get common denominators. So we have y minus 2, y squared minus 4, which is y plus 2, and y minus 2, since it's a difference of squares, and y plus 2. Okay, so let's put parentheses around our binomials, circle every unique occurrence, and cross out any duplicates. And that's all we have is y minus 2 and y plus 2. So our least common denominator is going to be y minus 2 and y plus 2. Okay, so ultimately that's going to be our denominator. We also have to figure out what values of y won't work because it'll make things undefined. So I'm going to show you, let's see, so if this denominator becomes 0, we have an undefined problem because denominators cannot be 0. So if y is equal to 2, it'll make it 0, and if y is equal to negative 2, it'll make it 0. So y cannot equal those values, and we need to keep that in mind so that when we get our answer, we can check it against this and make sure our answer is all right. Okay, but again, let's look at our least common denominator, y minus 2, y plus 2. Let's write parentheses around all of our binomials. So we have 4 over y minus 2, and we need to multiply that by y plus 2 over y plus 2. We can do that because y plus 2 over y plus 2 is 1. We can multiply anything by 1, and it enables us to get the denominator we want. Okay, the second fraction is 2y minus 3, and I'm going to go ahead and rewrite this as y minus 2y plus 2 instead of y squared minus 4. So that's the same denominator. We don't have to do anything about it. On the right, we have 5 over y plus 2. We want the same denominator. Okay, and what we find is that with all the common denominators, and we know y cannot be 2 or negative 2, we can just cancel them out, and we're left with 4y plus 2 minus, and then this negative sign needs to distribute, so for now I'm going to put it in parentheses. Oops. Equals 5y minus 2. So let's distribute. Now this is like having a minus 1 there, and it has to distribute to both of those. So it changes the value of the 3 to a positive. Okay, and then combining like terms, we get 2y plus 11 equals 5y minus 10. Subtracting 2y from both sides, we get 3y, 3y minus 10. And adding 10 to both sides, we get 21 equals 3y. Dividing by 3, we get 7 equals y. We check it against here, and it is okay because it doesn't equal any of our disallowed values. And just for fun, let's go ahead and check it. So plugging in y for everything, we have 4 over 7 minus 2, which is 4/5, minus 2 times 4 minus 3 is 8, minus 3 is 5 on top. 7 squared is 49, minus 4 is 45, and that should equal 5 over 7 plus 2 is 9. So let's lift this up, give us more space to write. 5 over 45, the 5's cancel. 5 goes into 5 one time, 5 goes into 45 9 times. And so we get 4/5 minus 1/9 equals 5/9. Okay, we can multiply everything by 45 to clear the fractions because 9 times 5 is 45. So 45 over 1 times 4/5 minus 45 over 1 times 1/9 equals 45 over 1 times 5/9. 5 goes into 5 one time, 5 goes into 45 9 times. 9 times 4 is 36. 9 goes into 9 once. 9 goes into 45 5 times. Minus 5 equals 9 goes into 9 once. And we see that 31 does not equal 25. So we made a mistake somewhere. So let's go back and look and be glad that we checked. First of all, let's check our check. We have 7 equals y, so 4 over 7 minus 2 minus 2 times, here's my mistake. I put a 4 in for my y and it should have been 7. So let's come over here and finish working this. So we have going to multiply everything by 45. Okay, and then we cancel. 5 goes into 5 once and into 45 9 times, so 9 times 4 is 36. The 45's cancel here, and 9 goes into 45 5 times, and we get 25 equals 25, and that checks. So let's go ahead and get rid of all of this because it was an error. Okay, so the moral of this story is to write down everything you do and be careful with it so that you can go back and check it quickly. So now we know that y does equal 7, and that is the answer to the problem. Number 7, by checking work records, a contractor finds that Peggy Ann can wire a home theater in 9 hours. It takes Matthew 7 hours to wire the same room. How long would it take them if they worked together? We have a formula for that. 1 over Peggy Ann's time plus 1 over Matthew's time equals 1 over the time it would take them to do it together. So we need to memorize this formula. Now let's plug in. Peggy Ann takes 9, Matthew takes 7, and we want to find time. Okay. So we have a 9, a 7, and a t, and the least common denominator is going to be 63t. We're going to multiply both sides by 63t. So we get 63t over 1 times 1/9 plus 63t over 1 times 1/7 equals 1 over t times 63t over 1. Okay, 9 goes into 9 one time, 9 goes into 63 7 times. That leaves 7t for our first term. This 7 sort of disappeared. 7 goes into 7 once, 7 goes into 63 9 times. So that leaves just plain old 9 for a second term. 9t for a second term. And then the t's cancel here and leaves 63. 9 and 7 are 16t equals 63. Dividing both sides by 16. So it takes them 63 over 16 hours, which is nearly 4 hours if they do it together. Number 8 is a function. A function means you have some kind of machine. It has an input, which is your domain, and an output, which is your range. So for instance, if this is a Coke machine and you're pushing a button here for Coke, that's your X, is pushing that button. You should get a Coke out, right? A Coke. You should not get a Dr. Pepper or a Sprite. So every time your X means push the Coke button, you should get a Coke out. There might be another Coke button here, and you want to get a Coke out there also, but as long as either one of these buttons you can push, as long as you don't get a Sprite or a Dr. Pepper out, you're okay. Now you might push this button here and get an orange soda out, and that's fine too. But what wouldn't be a function is if you pushed one of these buttons and every time you pushed it you got something different out. That would not be a function because it wouldn't function. Okay, let's look at this chart. Domain. You have 2, 5, and 19 that you are entering as an input into your machine. And the 2 always produces a 9, the 5 always produces an 8, and the 19 always produces a 9. Now notice, if you had another 2 that produced an 8, that means this would be like the machine where you press the same button, 2. And one time you might get a 9, another time you might get an 8. That would make it not a function. But since there are no 2 x values, no 2 values the same in the domain, this is a function.